Hello, Rhino researchers. Today we're going to explore states of matter such as solids, liquids, and gases through a dry ice investigation in which we make root beer. So one of the things one of our ingredients will be dry ice. And you may be asking yourself, dry ice? Well, that's kind of strange. How can ice be dry? But there is a special ice, and it is a solid form of carbon dioxide, and that's known as CO2. And in its solid form, carbon dioxide is at a temperature of negative 110 degrees Fahrenheit. That means it's 110 degrees below zero. And sublimation is what dry ice goes through. And that's the process of the dry ice in the solid state changing to a gas without the intermediate stage of a liquid. So let's look at this wonderful stuff. CO2, frozen CO2. It's very dangerous to work with your bare hands. So you definitely need tools. And I'm going to put some in there, and I'm going to put some dry ice in here. Look at that stuff. And we can just see how it's going through that sublimation that we talked about. I'm going to put some more in, just for kicks and giggles. Alright, so we already have the dry ice, our solid form of CO2, and it's in the bowl before we put anything else. I put some dry ice in this graduated cylinder, and I'm going to put a balloon over it. And we're going to see what, if anything, happens with that. Now, in our bowl, we have the solid form of dry ice. And then to continue with our root beer, I'm going to add sugar. Now, is this sugar a solid? It seems to pour like a liquid. That's something you need to think about. Is sugar, which pours like a liquid or a solid? I want you to think about that. Then I'm going to add water. Now, water is definitely a liquid. And look how we can get a really cool reaction with the dry ice and the water. Well, that's actually looking really cool going over the table. I want you to notice how the air that we breathe is floating up, but yet here we see a gas that sinks down. Why is it sinking down? I need for you to think about that, okay, as we continue. And I hear bubbling too. Sounds pretty cool. So now I'm going to add the 12 milliliters of root beer extract. Oh, it's smelling good. Yum. So, was the root beer extract a liquid? Something for you to think about. So, just to show you that the dry ice is still in here, there it is. There's one of them. If you can get a close-up in the bowl, that would be awesome. So I'm just stirring to mix it all up. The CO2 will provide the carbonization part of our drink. It'll be the bubbles, if you will. Now, if you notice, I have this candle, and the candle is burning. But what happens if I put more? Wow, that's like magic. It went out, and it wasn't from a liquid. It was from the gas, the CO2 gas. Why did the candle burn out? Why isn't it still lit? While we're still watching this mix, check out our balloon. It's inflating. From what? What could be going on right here? All we have is dry ice in the graduated cylinder, but the balloon is inflating on its own. Okay, back to our wonderful liquid here, or mixture. Now, is this going to be a mixture or a solution type of mixture? Yes. Remember, all solutions are mixtures. They're a special kind of mixture. But not all mixtures are solutions. So I want you to be thinking about what's going on when thinking about mixtures and solutions. And don't forget your solids, liquids, and gases as well. Now let's play around with some dry ice for a minute, okay? So I'm going to pull a chunk out because it takes a while for it to sublimate. Listen to that. Does somebody need to turn off their alarm clock? Did I hear an alarm clock? Oh, no, it's just the dry ice. It's sublimating. So it's turning into a gas so fast that the molecules are hitting against the metal, which is causing the vibration and the sound. How cool is that? And then let's try this one. Oops. Another reason you should probably be careful. Once again, bigger chunk, different kind of spoon. Look, it's turning into a gas. It's not turning into liquid. So this is a fast evaporation kind of thing. So fast that those particles are crazy and they're just hitting against the metal. That's it. All I have is dry ice, tongs, and a spoon. And I can create music. So let's check and see what's going on here. Also, I wanted to talk about liquid ice. So here's your dry ice and here's your liquid ice. We'll check on those in just a minute. But when you looked in the bottom of this bowl, you notice that the dry ice sat on the bottom. What does that tell us about its density? Right? The dry ice, I don't know, think about that. What about its density? I just love this fog. Now let's look at liquid ice, water ice, and we'll see if it floats or sinks. And can you see? What is it doing? What is our water ice doing? Looks like it's floating. Can you see that? So our water ice floats, but our dry ice sinks. I wonder why. What is causing that? Why would dry ice sink and water ice float? And I want you to notice something. This fog, if you will, is so dense, I can pour it. Look at that. How often can you pour it? Would the air that we breathe do that? Think about it. Here I go again. Very cool. So, my wonderful rhino researchers, it's about time for me to serve my concoction of root beer. Oh, one more thing. Let's visit our water ice and dry ice. I forgot about that. So, look at our water ice. It leaves a liquid. It leaves the paper wet. But our dry ice, nothing. Ponder that along with many other questions and thoughts when you complete your dry ice investigation worksheet. Have a great day.